If I create a video because of your comment, I'll give you a shout out. So be sure to let me know in the comments what you'd like to see. Alright, so I'm finally ready to start programming my PID algorithm. But, as you know, I like to do things in steps, in pieces. So, I just did my line sensor program, so I know that that's working. And I just, I did the motor driver circuit while it was outside of the robot. So I'm not sure which orientation the motors were in, so these might actually go backwards. So what I did was I opened up my example program for my TB67H420FTG motor driver, and I plugged in my pins 5, 6, 9 for the first motor. You have 5, 6 digitals and 9 PWM, and then we have the 7, 8 for digitals to control the direction, and 10 for PWM for motor B. Okay, and then I'm going to upload this, but first I have to plug in my microcontroller. Let's upload. Oh, Teensy didn't like that. Alright, that seemed to work. Okay, so I unplugged my USB from my computer, so because I'm going to plug in my battery. The motors will not work without the battery because the motors are getting their power directly from the battery through this regulator. So what I want to do first is jack up the back end on a piece of tape here, or a thing of tape, so that way it doesn't go driving off on me. Alright, and those are both going backwards. Okay, so all I have to do to fix that is just come here and switch my directional pins, 6 and 5, and then 8 and 7. And now, when I plug this back in, upload, unplug USB. Alright, forward, good. Alright, so now both motors are going forward. Okay, so now I know I have the right initialization code for my line sensor and for my motors. So let's get over to programming. Okay, so let's start a new sketch here. And I'll immediately save it as some name. We'll call this PID, cardboard PID bot. Alright. Now, I have my example code from my 2 other Arduino programs. So what I'll do is I'll go over to my line sensor example. I'll copy this library over. Oops. Paste that in. I will copy over all of this in the global define section. And this is going to be everything we need to set up the line sensors. Okay. And I'll delete this because that doesn't even pertain to my actual code. Okay, and then the next one we'll do motor driver properties. And we'll come over here, we'll go to the motor driver example, and the only thing I have to do here, and then I just have to remember that I'm not going to copy this over, I just have to remember that I have to driver init first in the setup function. So let's go back to my cardboard PID bot. We'll put that there, and then before I forget, I will put driver.init. Alright, so the driver is set up. I do want to copy the calibration code from the line follower, from the QTR sensor example. However, I don't want to put it in setup because it looks funky and ugly. So I'm going to create my own function called calibrate line sensor. Okay. And then I'll just go over here to my line sensor example. And all the calibration stuff was right here. We had a delay 500. Not necessarily needed, but I'll put it in there anyway. Let's see. All the way down. I don't really care to see what the actual values are, so I will just copy this section here. I'll put this in here. And then all I have to do is initialize line sensor array and call calibrate line sensor. Okay, and that's going to light up my LED like you saw in the previous video if you watched. It'll light up the LED, and while that's happening I need to wave the sensor over the line. Okay, and that's going to calibrate my line sensor. We're also going to need properties for our PID algorithm. So I'll put those here. And for my PIDs, I don't actually use an I term, I just use a P and D term. Typically I'd use a define for this, but I'll just use a variable. We'll call it double P. We'll define it as a const just because. And I don't know. So the way that I typically determine a p-value, an initial p-value, is I take the total error that I could possibly have, the max error I could possibly have. So if my goal is to be at 3,500, I'm going to have a max error of 3,500 because I'm either going to be too far off this way or I'm going to be too far off this way. So my max error is 3,500. Now my motor speed is 255. So when I have a maximum error of 3,500, I want my motor to be completely off. So I want to map that range of values from 0 to 3,500 to a range from 0 to 255. So what I would do is I would say 3,500 divided by 255. Oh, wrong way. 225. 255 divided by 3,500. 0.07. So we'll just start with 0.073. Okay, and I have no idea if this is going to work, but it's a good starting point. So then I have my D value. I don't like that it thinks it's already a... here, we'll change these. KP and KD. It's a typical thing for PID to call it a KD, that stands for constant. And with the D value, I don't tune my PIDs with both values until I have one known good value. So I do just a P until I get that tuned. So then we're going to need, I just know this off from experience, we're going to need an error. So it's going to be the last error that occurred. Oops, we'll call it last error. And we'll initialize it to 0. And that should be all we need. I'm not positive, but I'm just flying through this in the seat of my pants here. All right. So the first thing we're going to need to do is get our position. We can't do anything without knowing where we are. All right. So that was in our line sensor example. And that was this value here, or this function call here. All right, so get line position. Now, if you remember, if you watched the previous video, if you didn't, I'll run through it real quick. The value is going to be 7,000 if it's underneath this the eighth sensor over here, the far sensor, and it's going to be a value of 0 if it's underneath here. Okay, so let me try to do this. So my value is going to be 0 here and 7,000 here. That's the return value of this this read line function here. Okay, and I want my read line to be, oh, that's another thing I actually forgot. So let's go back up here and we'll set our goal. What is our goal? actually this doesn't need to be a double. We'll call it an int goal 3500 because we want to follow on the center. Now the beautiful thing about this is if we wanted to follow underneath the third sensor, we could just say I want my goal to be 2000, and that would make it follow underneath this third sensor. If we want to follow underneath the seventh sensor, we would just say that I want it to be 6000. Okay, so the goal being 3500 is going to be right in the middle because 7000 divided by 2 is 3500. All right, so we get our line position. Then we need to calculate our error. So what is our current error? Our current error is our goal minus our position. And it doesn't necessarily matter whether you say position minus goal or goal minus position. That's only going to change which motor goes forward and which motor goes backward, or which motor slows down and speeds up. So whether or not you put goal minus position or position minus goal, you may have to tweak some things later, but just know you don't have to necessarily put it this way. Okay, so now we know our error. We need to compute our PID. So I call it an adjustment. So we'll use an int for this. And this is going to be your PID algorithm. This is the meat of the algorithm. And it's simply KP times the current error. And so again, if my value is 3500 and I multiply it by 0.073, it's going to be a value of 255, which is going to turn that motor off. So if my value, if the farthest most sensor on both the left or the right sees the line, it's going to turn that corresponding motor off. Okay, and then even though D is 0 right now, this part won't matter, but we're going to do a KD times current error minus last error. Now right now last error is 0, so the first time this runs it's going to be a 0 anyway. And then after we do this, we want to store the error for the next increment. So last error equals the current error, because the next time around our current error is going to be the last error. And let me just add some comments here. Compute motor adjustment. Compute error from line. All right, and the last thing we need to do is just adjust our motors. So, you know, PID, it seems overwhelming, it seems complicated, it's really straightforward. There's a couple lines of code other than all that setup junk up there. Okay, so now at this point we adjust our motors. We either want to speed one up and slow one down. So what we'll do is driver dot, not sure, I don't recall what the function exactly was. Set motor A power. All right, so I'll just copy this. Okay, and it's going to be 255, which is the full power. And what I usually do is say, let's call it const unsigned care max speed. Okay, so the max speed we want our motors to go is 255. This way we can easily adjust the speed. If it's going too fast, we can just change it right here, and it will change it in our code for us. So then we'll just use max speed plus the adjustment, and we will copy this. Oh, that's messed up. All right, we will copy this and change this to set motor B power, and we're going to subtract from that one. Okay, and now one last step we have to do is there is a possibility that the adjustment is larger. So as you saw, my adjustment was actually 255.5, which is going to round to 256. But if I subtract 256 from 255, it's going to go back up over to 255 again. So we want to use a function called Constraint. Okay, so I'm going to cut this and I'm going to call Constraint, and it's going to say, what value do I want to constrain? I want to constrain this value. What's the lowest range that you want this to be? I don't want it to be anything lower than 0. And then what's the highest range you want it to be? I don't want it to be anything other than max speed. Okay? This way your motor will never exceed the max speed that you set, and it will never go below 0, so it won't be able to roll over. That's a very common mistake. So what I'll do is I'll just copy this. I'll paste it here and then just change that sign from a positive to a negative. Okay, and that really should be it. So let me hoist this bad boy up on a piece of tape again. Oh, good. Start recording for you. All right, so I'm going to plug my robot in to USB. I should have probably verified this before compiling. Oh, I forgot to include my library. So I'll go to my example here, copy cardboard PID bot, and we'll paste that there. Oh, forgot a semicolon. All right, let's see what happens. So when I plug this into the battery, first thing I'm going to do is I'm going to calibrate it. I'm not actually going to drive it around because, you know, obviously I have this tiny little space here. But what I'll do is I'll hold it up off the track and I'll wave it over here and we'll be able to see what's happening to the motors. Actually, let me do this real quick. This is going to be wet, so hopefully it doesn't squirt me in the face as these wheels are flying past 900 miles an hour. Alright, but now I've marked my wheels so you can kind of see how they're moving. Alright, so I will try to tuck this away. Okay, calibrate. Again, you just want to make sure it goes over white and black for every sensor. Alright, so now, oh, that's loud. Alright, so you can see it's actually going in reverse. Alright, so we're getting a little too erratic here. So what I'm going to do, we're going to, for one, slow this down a little bit. So max speed, we'll say 100. And also, since I'm lowering my max speed, I'm going to lower my KP. So I drop my max speed down to 100. So that's going to be, it's going to equate to 0.035. I don't know, I'll just make it 0.03 just to make it easier. So now if my max error is 3500 times 0.03, it's going to make an adjustment of 105. So that's going to actually shut my motors off. Alright, so let's try this. Let's plug this in, upload, reboot OK, plug this in, on the calibration. Oh Lord, I hate this paper. Wow, that is still cruising, holy cow. But where you can see, well actually, I don't know if you can see this, it's actually speeding up the motor and slowing this motor down which is the opposite of what I want. When I'm this side, I want... Let me shut this off. So what was happening was, as I was approaching this side of the line, this motor was speeding up, which would actually make me even go faster off the line. So in essence, this robot is avoiding the line, which means I either need to change, and this is why I said goal minus position or position minus goal isn't really going to make a difference. You either need to change this to position minus goal, or just swap these two, so this negative and this is positive. Okay, so that's the only difference. So now I can't believe those are going that fast at 100. But, let's see, all right. Upload. Okay. Plug this in. Calibrate. Alright, so this is what we want. So, holy cow, these things are really flying. So, as we approach this side of the line, this motor is slowing down almost to a complete stop. And this motor is speeding up. And then as we approach this side of the line, can't really see it, but this motor is going much slower, and this motor over here is speeding up. So that's exactly what we want. However, those things are hauling. So I am going to slow that down even more, because that is just ridiculous. It's very, very difficult to tune a PID when your robot is going very fast. So I'm going to bump this down to 50 and hope that's not, you can't go too low because then you'll lose a lot of the torque. So I'm going to try to go to 50 and see what that does. And then I will again drop this down by half. And we'll see what that does. Gotta make the teensy active. All right. Calibrate. And again, I would normally calibrate or punch in the hard code these values once I calibrated it once, but just for this. Oh, okay, this is much better. This is much better. So now they're not going too fast, but let me see if I can. I want to see if I can get this to. Try to get this to do this for you. Oh, my KP is way too low. That's not going to work. All right. Hey, take it easy, buddy. What is wrong with that? 1.5. Huh, that's interesting. It didn't seem to drop it down enough. Whoa. So I'll bump that up to 2. Just because I like to initially have my motors shut off when they reach the edge of the line, so that I know I have a very high KP, and then I can kind of lower it and increase it and just kind of see what happens to get a better value. So let's upload. Yeah, it's yelling at me about that, so I'll just manual reboot. Plug this in, calibrate. All right, that's better. Okay. So now we have it to the point where it actually stops the motor. So this is good. Oh, I see. Okay, it wasn't working on there. So now this should... Yeah, so you can see it actually followed pretty accurately. Now if I were to put it over here, it should go right toward the line. So you can see, it actually does a pretty good job, just off the bat. And over here. Woo! Wheelie. Alright, so I'll cut it off here, and we'll go on to tuning it on another video. Just a reminder, I will put a link to my blog, the article for building this robot with all the code, all the examples, right in there. So if you build this with the parts that I built, you can literally just plug the code in and it should, for the most part, work exactly as mine does. Obviously there's some differences in the motors, but beyond that, everything should work. And hope you enjoyed. Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.